Okay, so the formula is not very complicated as we saw in that last example, but the last example was only 6 data points and they were pretty nice numbers. So on Connect Math, what's going to happen with most of your questions is the data sets will actually be pretty long and the numbers might be not as nice to work with. So I'm going to show you guys how to do this in your calculator. That way you can have it a little bit easier when you do your homework questions. So for example 3, we're going to find the variance and standard deviation for the brand B paint. Okay, so what you want to do is take your 6 data values for brand B and put them into a list in your calculator. So to do that, you're going to go to Stat and then Edit and type those values from brand B into, I usually always use L1, so just do that. And then once you have that, you're going to go to the same place that we were going in the last section. So you want to go to one variable stats, which is found by doing stat, go over to calc, and it's the very top one there. And then just tell it that L1 is the list that you want to use. Okay, when you do that, it's going to generate a list of data values for you. And in the last section, we were looking at the mean, the X bar. Well, if you look down a little bit, let me see how far it is. It's the 5th one down on my list of statistics. And you'll see that there's actually a sigma X there. Okay, that's the one we want. That's our sigma. That's going to be the standard deviation. So if you round that to 1 decimal place, that comes out to be about 6.5. And then to go from sigma, which is the standard deviation, to the variance, which is sigma squared, we're obviously going to want to square that value. Okay, so the calculator actually does it in the opposite order that we do it when we do it by hand. So the calculator, you're always going to get your standard deviation first, and then you're going to have to square that value to get the variance. So it might be tempting to say, all right, I just figured out that sigma was approximately 6.5, and then you might think, okay, I'm just going to square 6.5. Well, if you square 6.5, you're going to get 42.25. And if this were a problem in Connect Math and you type that in, you would be told that that is wrong. Okay, and that's because 6.5 was an approximate value. So the weighted and the actual sigma value, as you saw in your calculator, it's like an irrational number that's kind of doesn't have any nice pattern to it. So instead of typing that in completely, the way to get that value from your calculator, I'll show you what keys to hit. You'll hit vars, which stands for variables. And then the 5th one down, you'll see it says statistics. Go there. And then you want to get the sigma X, okay, because that has the stored value for what sigma is from our previous problem, and it's exact. Okay, so go get sigma X, and then when it comes up on your screen, you're going to square that value, and that's going to give you a much better approximation for sigma squared. Okay, and that's going to come out to be about 41.7 when you actually round that to 1 decimal place. Okay, so what we saw was that the standard deviation of brand A was 17.1 and the standard deviation of brand B was 6.5. So we would say that the data is more variable for brand A if we're comparing those. So the larger the value, the more variable that it is. So I do just want to try to show you guys actually on a calculator how to run through some of those steps. Okay, so in the calculator, you'll go to, stat, edit, and then I already have the brand B values typed into my L1 list. So go ahead and do that if you haven't already. And then from there, you're going to go to stat, go over to calc, click enter on one of our stats. Okay, my L1 is already my list. Make sure your frequency list is empty for this, and then just go to calculate. Okay, and then the 5th one down here, you can see there's a little sigma X. and it's about 6.4549, so on. So when you round that to 1 decimal place, that's where we were getting the 6.5 from. Okay, so then to square this exact value, what you do is you'll click the vars key, which is next to your clear key. Okay, that's all of your stored variables. And then go down to number 5. Okay, and we want sigma x. So that's the 4th one down on mine. So click enter on that. That's going to bring it up on your main screen, and then you want to square that. So I usually use the caret key to square. Okay, so by doing it this way, you're squaring the exact sigma value, which means you're going to get, the exact answer for sigma squared. So that's where I'm getting the 41.7 when you round to the first decimal place there.
And that is quite a bit different than 42.25, right? That's.
Yeah, that is a significant difference.
It's more than 1% difference. So.
Yeah, so you would definitely get that marked wrong. And of course, just in general, you want to try to be as accurate as possible. Did you have any questions on the calculator part for that?
No, that seemed pretty clear to me. I assume that they're going to get a lot of practice at this, right?
Oh, they will definitely get tons of practice with this stuff. Okay, so one other topic we're going to look at is the variation and standard deviation for samples. So this is going to be really similar to what we were doing for populations. We do use different symbols though. So the symbol for sample variance is going to be a lowercase s squared. So sigma goes with population, s goes with sample, so s squared. And then for the sample standard deviation, that symbol is just going to be a lowercase s. And the formulas are really similar. The only thing really that's different with the samples is that instead of dividing by n, we're dividing by n minus 1. But we're actually not going to even worry about doing this by hand. I'm just going to show you guys how to do it in your calculator. And it's really similar to what we were just doing anyways. So example 4 says that the number of public school teacher strikes in Pennsylvania for a random sample of school years is shown. Find the sample variance and the sample standard deviation. Okay, and we have our 6 data values there. So what you want to do is put those values into a list in your calculator. So just go to L1, type those in, and then you'll go to one variable stats, tell it L1, and then we don't want the sigma. So right below sigma on that list of statistics that it pulls up is a lowercase s. It says like SX. So you'll take that value, round it to 1 decimal place. So you'll get 3.6. And then you're just going to square that value. So again, you want to go to vars or variables, go down to statistics, and then go down to the S. Okay, grab that, click enter, that'll pop it up on your main screen, and then you'll square that, and you should be getting about 13.1. So the sample standard deviation is 3.6, and the sample variance is 13.1. So it's the exact same process for population and sample. The only thing that's different is what symbol you're using and looking for in your calculator. Okay, and then example 5 says to find the sample variance and the sample standard deviation for the frequency distribution shown. And the data represents the number of miles that 20 runners ran during 1 week. Okay, so we can do this in our calculator, but since we have our frequency distribution table, we do have to go ahead and find the midpoints of all of those classes first. Okay, so if you remember, the midpoint is just where you take your 2 boundary values, add them together, and divide by 2. So you'll have to do that for all of those classes there. And these were actually the same values that we had in the previous section, so hopefully this looks familiar. So for our midpoints, we get 8, 13, 18, 23, 28, 33, and 38. Then what you can do is put your midpoints into L1 and your frequencies into L2. Frequencies always go into the second list. And then you're just going to do one variable statistics, L1, comma, L2. And then look for the sample variance or sample standard deviation. So that lowercase s, which will be about 8.3. And then do vars, stats, grab the s, square it, and then you'll get that the sample variance is about 68.7. So same process as far as finding these when it comes to a frequency distribution table, just the only thing is that you have to find the midpoints first.